Welcome to another episode of Terry's Notes, and today we're going to be looking at the January 2016 paper, question 3. Okay, so we have two organic molecules, compound D and E. Alright, now before I even read the rest of the question, let's look at what compound D is. Compound D is a carboxylic acid or an alkanoic acid, and the reason for this is because it has the COOH group present, right? So this is what makes the group acidic. So therefore this belongs to let me just name it one time. So we have 1, 2, 3 carbon, so therefore it'll be, remember, meat, we have 1 carbon. Eat, we have 2 carbons. Meat, eat, prop, we have 3 carbons. In this case we have 1, 2, 3 carbons, so therefore this is an acid and it is propanoic acid, right? So whenever you have an organic chemistry question, the first thing to do is identify what the compounds are, right? It will help you answer the question. So in the case of compound D, the functional group present is the OH group, which is an alcohol. So we check to see how many carbon atoms we have. We have 1, 2, 3, 4. If we have 4 carbon atoms, that is but. So therefore this is butanol, right? So we have an acid and an alcohol. Now they said compound D inhibits the growth of mold and bacteria and is used as a preservative. So compound D is the propanoic acid, right? State the name of compound D. Well, we've already done that. So it is propanoic acid, right? Identify which homologous series to which compound D belongs. Well, we just did that as well. So we say this is an alkanoic acid, or carboxylic acid. Anyone will be fine. And state one chemical property of compound D. Right, so it's an acid, so they want a chemical property, okay, not a physical property, chemical. So what can we say about it? If it's an acid, it's going to react with, let's say, sodium hydroxide, and it will give us a salt and water. Right? That's just one chemical property. We can also say that it reacts with sodium to produce sodium propanoate and hydrogen gas, anyone you want. Okay, let's do part B. Compound E is present in alarm pheromones that are produced by honeybees. State the name of compound E. Now we just did that here, right? E is, we said, is butanol, right? So I said state the name of compound E, so we can just say this is butanol, right? Identify the homologous series to which E belongs. So we said it's an alcohol, and write the general formula of this homologous series. So the general formula for the alcohol homologous series is H2N plus 1 OH. Let me just write this over. So it's CnH2n plus 1 OH. Right? Excuse the handwriting. Right? So this is general formula for the alcohol homologous series. Now we have 2 more compounds, F and G. So first thing, identify what is F. Now if you look at compound F, we are just seeing carbon to carbon bonds, right? And all we have are carbon and hydrogen atoms. So therefore this is an alkene, right? And we have 1, 2, 3, 4. So therefore, this is butane. Right? So it's an alkene. That's where it's again it's named from ANE. So therefore, we have 4 carbons. So it's but and it's butane. In the case of compound G now, we have a double bond present. So therefore, it's an alkene. Right? And again, we have 4 carbon atoms. So we can say it is butene. Right? Now, this let's state one physical property that is common to both compounds F and G. Now, here's this. You need to remember, if you can't remember like a physical property, think of things like state at room temperature, melting point, boiling point, those kinds of things. So they want a physical property, right? So now I know that butane is a gas at room temperature, right? Some countries they use butane as cooking gas. So we can say both of them are gases at room temperature. Right? You can also say they have low melting point and boiling point. Right? Anyone will work. Now they said state which compound F or G will react with bromine in the dark. Now they are asking us about the chemistry of an alkane and an alkene. Right? So we're using bromine in the dark. When we react in an alkane or alkene with bromine, we have one condition where we use UV light and one where we don't use UV light. So an alkene, which is compound G, will react with bromine in the dark, right? In the case of compound F, you need something like UV light in order for that reaction to take place, right? Because in the case of bromine, what you're going to have is something called an addition reaction, and the bromine adds itself across the double bond. So the answer is G. Okay. And I think they're going to ask us to draw the fully displayed structure when formed in the reaction. Okay, so we have let's see. So this is the structure that we're going to get. So we're going to have H. Now we just reacted to the bromine, right? So the bromine Br is going to add itself across the double bond, and the double bond is going to disappear. Notice that, eh? So some students, what they do, they add the bromine across the bond, and they forget that you need to remove the double bond that is here, right? So what some students might do is do this. BrC. But the problem is, look at this. In the case of this carbon atom, we have 1, 2, 3, 4, 5 bonds around the carbon, which is wrong. Right? So just remember, it's an addition reaction, and the bromine adds itself across the double bond, and the double bond disappears. Now, part 4, will compound F burn in air with a clean blue flame? Right? So they're asking about the chemistry of alkanes and alkenes. So just to recap, we have F was an alkane. So let me just write that. So F was an alkane, and G was an alkene. Right, so F is an alkane, and I'm asking us which one will F burn with a clear blue flame? And the answer to that is yes. Right? If we compare the chemistry of alkanes and alkenes, an alkene burns with a smoky flame, right? And the alkane burns with a clean blue flame. And the reason for that is that in the case of the alkene, you have a higher percentage of carbon within the molecule than hydrogen, right? They said write an balance equation for the reaction that occurs between compound F as it burns in air. What is F? Alright, so F was butane, right? So that's C. Okay. Alright, so butane is C4H10. Could double check that. We have 1, 2, 3, 4 carbons, and we have 10 hydrogens, so it's C4H10. And we're gonna burn that in oxygen. When you burn a hydrocarbon in oxygen, we get carbon dioxide and water, so it'll be CO2 plus H2O. Now, this is where students they lose a little mark here because they can't balance the equation. So what you do, you have 4 carbons here, so we know we need to put 4 here. We have 10 hydrogen, so we're going to put 5 here. Now the oxygens will not be balanced most of the times, so we have 4 2s are 8 oxygen here, and we have 5 here, right? So that is 8 and 2, 10 and 3, 13. So what we need to do is to put 13 over 2 in front of this, and we can write over that as 2C4H10 plus 13O2 produces 8CO2 plus 10 H2O. If you put this, you should be able to get the answer correctly. Or if you want to get rid of the 13 over 2, we multiply every single term here by 2. So we end up with 2C4H10. 13 over 2 by 2 will give me 13. 4 2s are 8 and 5 2s are 10. Right? Whichever one you prefer. State 2 properties of hydrocarbons that make them good fuels. Okay, well, we can say that from your thermochemistry, your enthalpy change of combustion, so delta H of combustion, is high, meaning that we produce a large amount of heat when we burn a hydrocarbon. Also, we can say that it's either a gas or liquid at room temperature, right? And that allows for us to be able to transport the fuel easily from one location to the next via pipelines or anything like that. What other properties? Right? It combusts easily, right? It's not difficult to light gasoline, right? All we need is a spark to ignite it. So any 2 properties that you can think of, and it's reasonable on what makes it a good fuel, will be accepted. Okay? So organic chemistry is a question that can be very, very easy, right? And chemistry is not something that you can cram overnight. You need to be reading your notes over and over. Okay?